Algebra 2, 6-2, inverse functions and relations. So let's do a little example here to see what we're talking about. An inverse relation is when I have, let's say I have this relation here. A equals 1, 5, 2, 6, and 3, 7. And here's my inverse relation. 5, 1, 6, 2, and 7, 3. So hopefully as you look at this, you see that an inverse relation is when you just swap the x and the y values. Notice here I've got x is 1 and y is 5, and I just switched them. X is now 5, y is now 1. So that's all we're doing, is switching x and y. Or swapping, exchanging. All right, inverse relation. Now an inverse function looks like this. I've got f of x. My inverse to f of x is f with this little -1 up here, which is saying inverse of f of x. And so when we say this here, we say inverse of f of x. Let's see what this looks like as a function. So here is an example. F of x equals x minus 4. And I want to find the inverse here. So first what we do is we take this f of x and we just put y in its place. Y equals x minus 4. So here's step 1. Well, actually, we'll do a little bit longer step 1 here. We're gonna change it to x and y, and then we're gonna swap x and y. X equals y minus 4. So we'll make that our full first step. Step 1, swap or exchange x and y. Okay. Step 2 and all the way down to the end is solve for y. So that's what we're going to do. I'm going to add 4 to both sides. So I have x plus 4 equals y. Now, x plus 4 equals y is the same as y equals x plus 4, right? Hopefully we understand that. Now, I've solved for y. There's one more thing I need to do here, and that is I need to write it inverse of f of x equals x plus 4. So I need to swap, I need to, let's see, step 3. Exchange y for inverse of f of x. Okay. So here's what we're going to do now. I'm going to do an example. And this one is find f of 6 and inverse of f of 2. All right, let's see what I'm talking about here. So we're using this same equation up here still. I'm just going to kind of go like this so that we see. We're still using this f of x equals x minus 4. Okay, so f of 6 is 6 minus 4. So f of 6, x minus 4 is 2. Okay, that's cool. All right, now the inverse of f of 2 is where I am now going to use my inverse function to plug this 2 in. So inverse of f of 2 is 2 plus 4. So I'm using this equation here. So inverse of f of 2 equals 2 plus 4, which is 6. Now, notice something here. If I were to plug in 6 for x, I would get 2 as my y value. If I were to plug in 2 for x, I would get 6 for my y value. Interesting. Notice how these are inverses? Interesting. All right, let's graph an inverse. Graph of inverse. So I've got f of x equals 2x minus 5. So let's graph this first. (2x minus 5). So if I'm going to graph this, I use my y-intercept first. I go down 5. 1, 2, 3, 4, 5. Put a point right there. And then I rewrite my slope 2 over 1. I go up 2 to the right 1. 1, 2 to the right 1. 1, 2 to the right 1. And let's do one more. 1, 2 to the right 1. And then, I made that a little bit too far. There we go. Then I want to draw a line that goes like this. Okay, should be a perfectly straight line. All right, now my inverse. So I'm going to do my inverse. Now I could go through all the trouble of finding the inverse of f of x, swapping the y and the x, and then solving for y again. Or I could do something else. Well, I could do two other things. But what I can do is I can make a t-table here of x, of f of x, okay. And when I plug in x, or when I plug in 0 for x, I get -5 here. When I plug in 1 for x, I get -3 for 5. When I plug in 2 for x, I get -1. And let's plug in 3 for x as well. 3 for x, I get 6 minus 5 is 1. All right, now let's draw a t-table that is the inverse. So here's my inverse t-table. And my inverse, I just swap x and y. So I just go -5, 0, -3, 1, -1, 2, and 1, 3. So I just swap those. Now I'm just going to find these points. -5, 0, 1, 2, 3, 4, 5, 0. -3, 1. -1, 2. And 1, +3. Gosh, who made these points on here? Not very good. All right. And then I'm going to draw my inverse. And I should have, if I were to draw this perfectly, and this, it's okay, it's drawn all right, it's not perfect. I should be able to draw a line that is 45-degree angle at the origin. And I should have perfect symmetry if I were to look at these lines here. The f of x and the inverse of f of x should be perfectly symmetrical or mirror images of one another over this line here. This line is y equals -x or -y equals x. Oh, no, it's not negative. Why am I saying negative? I'm sorry. Y equals x. I wrote it before and it looked, on my old notes, it looks like negative. I'm going to rewrite it over here, y equals x. This line here is y equals x. And your inverse is going to just flip over this line. So that's what the significance of this line is. That sometimes it's kind of hard to write that out, or to draw that, to figure out exactly how that's supposed to look. So sometimes it's way easier just to pick some points and do the inverse of those points and then map that out and just follow them. This is probably the easiest way to graph the inverse. And when if you get this on a test, that's the way I suggest you do it. All right, let's graph some more inverses. Sounds good. Ooh, you try. Already a you try? All right. So we're graphing, again, graph f of x and the inverse of f of x. This time we have a little bit more difficult here. X squared plus 1. So hopefully you remember how to graph a parabola, x squared. We've got a parabola. All right. So go ahead and graph this parabola, and then graph the inverse of this parabola, and we'll check out how you did. All right, go. Okay, let's see how you did. So the parabola should, it's going to look like this. And it's going to be pointed up because I have a positive a value here. And it's going to start at 1 right here. Or that's where the vertex is going to be. I can check my vertex by saying the x value of my vertex equals negative b over 2a. Okay, there we go. Having some math problems. So negative b, that's 0, because there's no b value here, it's just 0. So my whole thing is going to be 0. So my x value is 0. When I plug 0 in for x, I get 1. So there's my vertex at 0, 1. So I'm just going to do a t-table. I'm going to do 2 points on each side of 0. So there's my 0, 1, there's my vertex. Look at negative 1 and negative 2, positive 1 and positive 2. And that I'll get my good graph here. If I plug in 1, I get 1 times 1 is 1 plus 1 is 2. Plug in 2, I get 4 plus 1 is 5. Now, if I plug these negative 1 in here, negative 1 times negative 1 is positive 1 plus 1 is 2. I get positive 4 plus 1 is 5. So let's plot those points. 1, 2. So negative 2, positive 5, negative 1, positive 2, oops, 2, not 3, 0, 1, 1, 2, and 2, 5. All right, so here is f of x. All right. Now, I could draw y equals x here, and then I could turn it this way so that I can see, okay, this shape should come in like this. That's kind of my mirror image here. But, I don't know, I'm having a hard time with this. So I'm going to just plot these points and make it easier to find that. So I'm going to say the inverse here. So I'm just going to swap x and y, or exchange x and y. 5, negative 2, 2, negative 1, 1, 0, 2, 1, 5, 2. 5, negative 2, 2, negative 1, 1, 0, 2, positive 1, and 5, positive 2. And so there is my graph. There we go. And if I go this way, you can see they are, perfectly, exactly mirror images of one another along y equals x. All right, let's do one more. F of x equals x cubed. So draw your coordinate plane. And here I'm going to get you set up. I'm even going to give you the points to plug in for x, all right, the values for x. -2, -1, 0, 1, and 2. Okay, plug in these values for x, draw your shape. After you find your y values, of course, then switch them and draw that one as the inverse. Okay, ready? Pause and go. All right, let's see how you did. -2 times -2 is positive 4. Positive 4 times -2 is -8. -1 times -1 is positive 1 times -1 is -1. 0 cubed is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. All right, so that's that one. So let's plug in these points. 0, 0. I should make these, oh no, I got 8 to go, so. So I've got 0, 0, I've got -1, -1, and I've got -2, 8, which is going to be way down here somewhere. And then I've got 1, 1, and 2, 8, which is going to be up here. And so this looks like that. Okay. Now, if I were to draw my y equals x here, and I turn this, I could maybe figure out how to draw this as the inverse, but I don't know. I'm going to make some points and see what happens. Okay, I'm just going to swap x and y. -2, 8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Okay, so let's start with 0, 0. Boop, there it is. 1, 1. Oh, -1, -1. Okay, sharing those points. Now, -8, -2. So -8 is way over here, and -2 is right here. Positive 8 is over here, positive 2 is over here. So this one goes like this. Like that. Here, oops, that went a little bit too far. Now if I look at this, right down the middle, it's a mirror image there, looks pretty good. And that is how you do the inverse of x cubed. Last part here, we're going to verify that two functions are inverses. So here's an example. We're just going to do this one example. F of x equals 3x plus 9, and g of x equals 1/3 x minus 3. So we're just going to find out whether these two are inverses of one another. And the way to do that is just to find the inverse of one of them and see if they match when you're all done. So it could be either one. I'm going to choose to do the inverse of f of x and see if it ends up looking the same as g of x. And if they look the same, we have inverses. If they don't, we don't have inverses. So I'm just going to swap y and x. So x equals 3y plus 9, and then I'm going to solve for y. So I'm going to subtract 9 from both sides. So I've got x minus 9 equals 3y. I've got to divide by 3. All of the terms get divided by 3. And so now I've got 1/3 x minus 3 equals y. Now I can just take this y and put it over here, right? Y equals 1/3 x minus 3. Hey look, they're the same. Yes, these are inverses. And that's how you do it. So do some more examples on the homework. Again, just like 6-1, practice, practice, practice in order to really understand this stuff and be able to use it. All right, good luck on the homework.